Hello friends, welcome to my channel. Let's have a look at problem 100, theme tree. This is an easy but very interesting problem, so we're going to practice recursion and traversal solution in iterative format. So let's first look at the statement. So given the roots of two binary trees, P and Q, write a function to check if they are the same or not. So two binary trees are considered the same if they are structurally identical and the nodes have the same value. So in example 1, so the return is true. The two binary trees are structurally the same and the node values are correspondingly the same. So in example 2, so the return is false. Actually, their structure are different. So in example 3, so the return is also false. So because the structure is the same, but the values are different. So the constraints on this problem are the following. First, the number of nodes in both trees is in the range from 0 to 100, a closed interval. So, this actually tells us one of the nodes or both the two nodes representing the tree can be null. So the node value is unbounded in absolute value by 10 to the power 4. So with that said, I guess let's look at the method. So here we're going to present two formats of solutions. The first one is recursion. It's actually suited for the binary tree data structure. And the second one is a practice of traversal solution in iterative format, so which means to understand the finer details. So the analysis or general idea is the following. First, so tree can be defined recursively. So it can be very convenient when we approach a problem related to tree or binary tree or binary search tree, and then by recursion if proper. Traversal is actually an important basic technique to check information in graph or tree or binary search tree or general graph. So we're going to explain the code line by line, and the code actually we feel they speak themselves. So before we write the code, let's look at some extensions. First, how to check if two binary search trees are structurally the same. So this is actually an interesting question to try. And secondly, we can check the problem for doing valid binary search tree. That is the Leetcode problem 1998. So it's also good to practice. So with that said, let's look at the solutions we're going to present. So first, I'm going to write a solution using recursion. So sometimes when we write a recursion solution, we feel that the logic, the set logic is important. So here, in order to do the recursion here, I'm going to first check a case is that if not P and not Q. So in this case, both the two trees are actually null. So we're going to return true in this case. Then the other condition is that at least one of the tree is not null, right? So in this case, so if not P, then P is not null, but Q is null. In this case, we're going to return false. So another else if block is not Q. So in this case, we have P not null, but Q is null, and then we're going to return false too. So in the other case, so both P and Q are not null. So because P and Q are not null, then we can look at their left subtree and the right subtree respectively, right? So in this case, we're going to return first. We need to check if their value is the same. That is, P value equals Q value. So this check is valid because both P and Q are not empty. So we need the left subtree and the right subtree are satisfying the value condition and the structure condition. So that is a self-call. let me just use self is, let me see, is symmetry. Then we're going to use p left and q left, and another self call, self is symmetry, so p right and q right. So the main logic actually is here, but the relation or the logic relation between the if and else and the if and else are also important. So with that said, actually, so this snippet of code consists of a valid solution to this problem. Let's do a special case check. Yeah, it passes the first example, that is a true case. So now let's do a generic case check. Yeah, it passes all the generic cases. So with this format done, so let's try to write a solution in the iterative format. Let's call this solution v1, and then let's write a iterative format. So iterative format. So for this, we're going to use traversal. So I'm going to initialize a container. So we can use it as a stack or queue. Both are okay in general. So here let's use a stack. So I'm going to store a tuple, so which consists of the two tree nodes. So then we are going to do the traversal val container. So we're going to pop, right? So p and q, the two nodes, is container pop. Then the first condition we're going to check is if both p and q are not null and their value are the same. So p value equals q value. So we can check the third condition only if both p and q are the same, right? Are not null, right? So with that said, in this case, we're going to push some the left subtree and the right subtree to the container if we have. So in this case, we're going to container. So we extend this container. So we can put here a list of tuples representing the left and right, right? P left, Q left, and P right, Q right. So that's it for this step. So otherwise, so we're going to consider if P or Q. So because we have checked this if, so if P, then we have not Q, or if Q, we have not P. So in this case, so we're going to return false. So if after this while loop nothing returned, so we're going to return true. So that's a format of solution, so basically in an iterative fashion. So let's do a special case check first. Yeah, it passes the first example. Now let's do a generic case check. Yeah, it passes all the generic cases. I guess that's the two formats of solutions we would like to share here. And just to repeat the consideration. First, if we have problems related to iterative data structures like tree, binary search tree, or binary tree, so we can think of recursion. And sometimes it's actually beneficial to write the code in an iterative format, because when we do the traversal, we can retrieve information, we can write up information or complex logic to address difficult problems. So with that said, I guess that's about it for this video. Thank you very much.